दोस्तों वेलकम टू फॉर योर क्लासेस. Today we will study one of the most important chapter of the physics, that is the light. This chapter is important for academic as well as competitive examinations. So we will see this chapter in the detail, and we will see this chapter in three parts so that each and every doubt is clear to the students who are going to appear in the board examinations, as well as a broad idea, a general idea is given to the students who will face the competitive examinations, because almost all the competitive examinations there will be a question from the chapter of the light where the general science is a common syllabus. Starting from, I will try to clear all the confusions. Study with me till the last. So this chapter of the light, now we can see all the items available in my room. You can see all the items available around you. But if the light is switched off and if there is a dark in the room, we cannot see anything. What does it mean? In the presence of tube light, sunlight, item is visible, but in the absence of the light, item is not visible. Why? That means some information is coming from any object to our eyes and our sensors are able to see that. But in the absence of the light, that information is not coming to our eyes. This is due to the reflection of the light. When the light is reflected to the any object, after reflection, that light is coming to our eyes, so we are able to see that object. In the previous classes, we have seen the light has few properties. It travels in the straight line, it follows the rules of the reflection, it follows the refraction. So we will study this chapter part by part. Today we are going to study refraction of the light. After that we will see the reflection of the light. What is the refraction of the light? When the light travels in any medium, its velocity, its speed is not changed. But when the light travels through certain medium, due to the density of that medium, the speed of the light is changed. Due to this change of the light, the path or the direction of the incoming rays is changed. This phenomena is called refraction. In a nutshell, deviation from its path, disturbance from its path, moving away from its own path of the light rays is called the refraction. So we will see this phenomena in detail. When there is a window glass, sunlight is, if there is a huge slab, glass slab is kept here, this will not happen. There will be a deviation of the path, because due to the density of this material of the glass slab, this light rays will deviate from its path, and while coming out from its parts, this will be disturbed. This you can see practically if you keep a pencil in a glass water. From the top, if you see, you will see that your pencil is bent. But if you take it out, it is not there. These all are due to refraction of the light. Now we will see the refraction of the light through spherical glasses. Once there was a plain glass, the light traveled straight. But when this glass thickness was changed, the light will not travel straight, because due to variation of this thickness of the lens, it will deviate the path of the light rays to certain point. Due to this, the ray will not travel in the straight line. So we will see the deviation of the light through spherical glasses. There are two types of lenses. Spherical glasses will be called lenses, through which you can see. There are two types of lenses are there, convex and concave. What is convex? One which is thicker from mid and thinner at the edges. It is convex. हिंदी में उत्तल लेंस बोला जाता है. Another one is concave, which is thinner from the midway and thicker at the edges. Due to this variation, because this density and the thickness of the lenses are not even throughout, they will deviate the path of the rays. Now we will see how they will deviate, what are the pattern to deviate, and what are the common rules while this deviation is to be studied and is to be kept in the mind. Now let us see. Before going, you should know two more things. There is a lens. Light rays are coming. Depending upon its capacity of the lens, which is called the power of the lens, which is generally the thickness of the lens in between, it will divert the path of the rays to a certain point, which is called focus point, denoted as F. So you have to keep it in mind whenever the light rays are coming and passing through a convex lens, depending upon its capacity, how much it can converge, how much it can focus, it will direct these rays to a common point, which is called focus point. So you have to keep this in your mind, that when the light rays are coming, they will be directed to a certain point. This is called focus point. In the first figure, you can see I have made a convex lens, and the left side F1, 2F1, F2, 2F2 is written. Let us know what is this. Since it is a lens, rays can be, while studying this chapter, the rays are made to come from the left side and the image are formed to the other side. So this is F1, matlab means this focus, this is the focus, and 2F means the double distance of the focus. In the other side, if you see, F2 is the same focus point, 2F2 is the double of the focus point. So this is the pattern you have to make while doing the practice of this chapter. Many conditions may be made, may be studied of the making of the diagram, but there are the common points which are to be studied in a nutshell. Suppose an object is kept beyond 2F, double distance of the focus. It is kept beyond double distance of focus, which will be called as 2F. So let us study what will happen to the image of that object. This object, rays will be coming from top to bottom. Infinitive rays will be coming and striking to the lens, passing through the lens. But in the schematic diagram, we have to take at least two rays to form an object. One rays will be made to come out from the top. When this ray will be passed through lens, it will be diverted from its focus. So I am passing through its focus because the property of the focus point is it itself says from where the incoming rays are made to focus. So this is the focus point. The rays will be made to pass. This is the pattern which you should follow to make the schematic diagram. And as I said, at least two rays are required to form an image. So another image is to be passed through the center point of the lens. Though infinitive rays will be starting from here and passing through the lens, but can you plot, can you sketch on a diagram? No. So you need two rays to make the image. Second ray is to be passed through focus point, through the center point. Now, what is happening? One ray I made to pass through this focus point, and the ray I made to pass through the center point, which is called optical center. Now what happened? These two rays have crossed each other at this point. You can see the top portion came to the bottom portion. Image is not formed to the upper side. So this image is inverted. Means the image of this object is made here. The image is inverted. Image is real because these two rays are meeting here, and image is between F2 and 2F2. Means if an object is kept beyond 2F, the images will be formed other side between F and 2F. Whatever pattern I try to make you understand, the same pattern of passing of the rays. One ray is to be made parallel to this axis, and that ray has to pass through focus point only, and the ray is to be made to pass through optical center. Let us meet at any point. Wherever they will meet, they will make an image. Irrespective of the position of this object, you have to take two rays, one passing parallel and passing through focus point, and the straight rays passing through the optical center. Let us meet at anywhere. Where they will meet, image will be there. You need not to muck up anything. Just follow this pattern. Again, I am reminding you, one ray parallel to the axis that will pass through focus, and the ray passing through the optical center. Let us meet anywhere. If they are not meeting, we will see that condition also. In the second case, you can see this is the optical center, this is the focus, this is the 2F, again this side F2 and 2F2. Let us make at the top. See, the second situation is that object is kept at the double distance of the focus, that is 2F. So let us see what will happen, what will be the position of that image and how it is formed. In this case, again we'll follow the same pattern. One ray is to be passed through parallel, and it will pass through focus point only. Another ray has to pass through this optical center. So these two rays are meeting just below the 2F. Means this is just due to that my scale was just disturbed. If you make correctly and take the help of scale on piece of paper, you will get the exact image. Means if the object is kept at a 2f, the image will be formed at the 2f only, but image will be inverted and it is made below the axis, and image will be real because the two rays are really meeting. So this is the second case. I did nothing. I followed my two sentences which I started in the beginning. One has to follow, one has to travel straight and is to be passed through focus, and another has to travel through optical center. Let us meet anywhere. Now see the third case. This is the focus. This is the 2f. This is the focus. This is the 2f. What is happening? If the object is kept between f and 2f, what is happening? Let us make one straight line. This is straight line. Again, what will happen? These rays will be passed through focus point only. What will happen to the another ray? Another ray will pass through optical center. What is happening? These two rays are meeting here. Object will be made here. But what is the position? This is beyond 2f. Means if the object is kept between focus and the double distance of the focus, that is between f and 2f, the image will be formed another side beyond 2f, inverted image and the real image, because these rays are meeting. So these 3 points are clear. Now let us see the another one. One chance may be there. This is the focus. This is the 2f focus. This is the again focus. This is the 2 focus. Second focus. That means double distance of the focus. What is happening? The ray will be, now let us make this lens a little bit bigger. What will happen? The first ray will pass through focus point only. First ray will pass through focus point only. Second ray will pass through optical center only. Sorry. What is happening? These two rays are parallel to each other. If the two rays are traveling parallel, they will never cross, they will never meet, they will never join, they will never collide. Once these two rays are not meeting to each other, they will never make an image. So, if an object is kept at the focus point of a convex lens, the image will be not formed. You take one convex lens, try to keep any object at its focus, you cannot see. Total blur image is coming, you will not be able to see. Because the rays are going to the infinitive. They will never meet, we do not know where they will meet, image will not be formed. The another case is there. The object is, this is the focus, this is the 2f, this is the focus, this is the 2f. Object is kept between focus and the lens. What is happening? In this case also, the rays will be passed through focus point only. And what will happen? And the ray will pass through its optical center. Now you can see very clearly the distance between these two rays which are coming out from the lens is getting increased slowly and slowly. Once the two rays are getting increased, the distance between two rays are increasing gradually and continuously. They will never meet. But if I draw line behind this, what will happen? They seems to meet here. these dotted rays are seems to meet here, means practically they will not means. That means the original image or real image will not be made, but a virtual image, imaginary image will be made. In this case, when the object is kept between the focus and the lens, the image is not real. Image is large in size also. That's why the person who is not able to read the nearby newspaper or the small letters of any book, he uses one convex lens, then he is able to read, because the virtual image of that letters is made little bit larger, so he is able to read. So these reason we have to study, that is, if the light rays are coming from very far distance, if they are coming from infinitive, they are considered to be coming from infinitive, means sunlight is coming from sun, and you have taken one lens in your hand. What will happen in that case? Again, the formula, the rules is to be followed in the same way. These light rays, again, they will pass through the focus only, What will happen? These rays are meeting at the focus. You can see they are not meeting here. They are not meeting here. They are meeting at focus. That means they are meeting at a center. In this case, what will happen? If the light rays are coming from infinitive, they will be focused to the focus point of the convex lens depending upon its capacity. That's why if you take one convex lens or hand lens or magnifier lens in your hand and focus, keep in the sunlight and focus on a piece of paper exactly on the focus point, in the few seconds paper is ready to burn, because all the rays are directed to a center point, to a focus point. This is the last position. On the basis of this only telescope and all are made, because the image from the very long distance is coming, they are focused to a center point, and again with the help of one more convex lens, this point is kept in a such a way, this is between focus and the optical center of this one. So again the large image according to this position you can get. On the principle of this only telescope is made. You will see the refraction through concave lens. In the convex lens you have seen the light rays are focused, diverted towards its focus point depending upon its capacity of the lens, power of the lens. Same phenomena will happen in the case of concave lens also. Concave lens is thinner from concave lens. What is happening? You can see when the light rays are coming and is striking to this lens, as I told in the earlier, there is a change in the media of the light traveling, so speed of the light will be changed. Due to this, the path of the light rays will be changed. Again, while exiting from this lens, the light rays will leave this lens and again enter into another medium, that is air. Again path will be diverted. So the light coming parallel to the principal axis will be diverted towards outside or from outside the principal axis. Due to this diversion of the rays, because these rays are diverted, this is called divergent lens. And due to the property of converging, this convex lens is called convergent lens. It's synonyms of these two lenses. So let us study a refraction of light through concave lenses. As you have seen, again here F to F I will make. In this case, in the case of convex lens, the concave lens, these rays are not diverted, not pointed towards any point, so they never meet to any axis or surface. But if you draw these lines imaginary to a point, they seems to meet here, but not exactly, but not really. So this imaginary point is the focus point. You can understand in that way the capacity of diverging the rays will decide the power of the concave lens. It will decide the focus of the concave lens. So in how much capacity will use this property in the image formation. Here is an image. Same formula, same rule will use. One ray will be passing parallel to the principal axis. Depending upon the capacity, this will be diverted outside. But if I draw a backward line, it should pass through the focus. Another line we use to pass through the optical center. Here these two are crossing, but they are crossing imaginary, because the first ray was diverted outside. We have drawn an imaginary line. So here virtual image will only form, as two rays are not really crossing to each other. In this case, you have seen the image is virtual, image is straight, not inverted, and image is small. In the all cases of, in the all positions of the concave lens, if you keep anywhere you keep, the same phenomena will happen. The size of the object, size of the image formed will be smaller. Image will be imaginary, because they will never cross to each other. Two rays will never cross to each other. Image will be imaginary, size will be small and straight. In all positions, the same formula will be utilized. This will pass through focus. This will pass through. Again, small image will be here. So in the concave lens, image is smaller, virtual and straight. By this, the refraction of light through spherical surface is over. In the next class, we will see refraction of light through glass slab, denser medium, how the medium changes, how the velocity change of the light.